right, as we're moving forward here, we are now going to learn how to solve logarithms. There's a couple different examples, the different scenarios that we're going to run into. So I've just kind of started us out with some examples, and we're going to work through there. We remember our log properties from our last unit, so condensing, rewriting, all that good stuff, that's going to come into play. All right, so we're starting out pretty basic here. I have a log equaling a log. If we notice, this is log base 13 and log base 13. Well, if log base 13 equals log base 13, then we also know that 3x minus 4 has to equal 2x plus 6. So if log equals a log, those insides have to be equal. Okay, that is called the equality property. And because those are equal, we're just going to solve this, and that's going to be our solution. So all I have to do is solve this linear equation here. I'm going to minus my 2x over. So I have x minus 4 equals 6. Add 4 over, and my solution is x equals 10. So if we notice, I can plug that back in. I'm going to have 30 minus 4, which is 26. And that's 20 plus 6 is 26. So boom, there's my answer. What x value is going to make those logs equal? Pretty simple, right? So we have the same setup here, except instead of it being a linear function, we're going to end up with a quadratic function. So let's take a look. Log base 4 equals log base 4. So 12p plus 3 has to equal p squared plus 23. So this one's a little bit harder because we have a p squared, which means we're dealing with a quadratic. So to solve a quadratic, if we're going to try to solve by factoring, we need to make sure it's set equal to 0. So I'm going to move this over to keep my p squared positive. So I'm going to have p squared minus 12p plus 20. Minus the 12p over 23 minus 3, we get 20. So the factors of 20 that'll equal 12, I'm going to use 10 and 2, and they're both negative. So that's p minus 10 times p minus 2. So my solutions are 10 and 2. So in this case, both the 10 and the 2 will be solutions for this logarithm equation. All right. So my last two problems, they step it up just a little bit. So let's take a look at these guys. The difference here is I have a log plus a log equaling a log. They all have the same base, but I need this to be one log equaling one log. But I know how to condense these two logs into one with this addition. So if I condense this, I get log base 9 of 5x minus 10 equals log base 9 of 49. So addition condensed to multiplication, so 5 times x, 5 times negative 2. And now I have a log equaling a log, so I can solve 5x minus 10 equals 49. So I'm going to add my 10 over. 5x equals 59. And I divide by 5. So x equals 59 fifths. And there's my solution. Okay? With our natural logs, the same thing happens. Remember, they're still a log. Their base is just e. So I'm going to condense here. Subtraction condenses to division. So that's going to give me 2 over x plus 1. And now I have a natural log equaling a natural log. So 2 over x plus 1 equals 61. Here, x is in the denominator, so I'm going to have to multiply both sides by x plus 1 to be able to solve for x. So multiply both sides here. I get 2 equals 61x plus 61. So I'm going to go ahead and minus my 61 over. That's going to give me negative 59 equals 61x. And then I divide by 61. So x equals negative 59 over 61. And there's my solution. Computer's asleep. Hopefully it's still recording. But that's all it is. As long as we remember our condensing properties, once we have a log equaling a log, those bases are the same. So using that equality property, we can just solve for the inside of our logarithms. Okay, good luck and solve on.